Hello Legacy students, so today we're going to solve logarithmic equations, aka solving equations that contain a log. You're going to want your notebook today, pencil, and then a scientific calculator as well. So, why are we learning about logarithms? Well, ultimately, these logarithms show up a lot in real life. One in particular is tornadoes. So, most tornadoes last less than an hour, travel less than 20 miles. The speed of the wind near the center of the tornado is related to the distance the tornado travels by that particular predictive model. So, in 2013, there was a tornado that struck Moore, Oklahoma, and it traveled a distance of approximately 17 miles. So we want to find out what was the estimated wind speed. Well, ultimately what we'd want to do is take that 17 miles and plug it in for D, right? And we would get a value of 179.43. So that was the estimated wind speed. So notice, guys, the kind of problems that we can solve using when we have equations with logs in them. Couple of examples of the destruction that happened on from that Moore, Oklahoma earthquake. So, what are we focusing on today? We're focusing, how do you solve an equation that has a log in it? How can let's say if we didn't know the distance here, but we knew our wind speed. How could we get that distance based on that information? So, that's what we're going to want to learn how to solve. So first kinds of equations that you'll be looking at is when you have a log on both sides. Ultimately, guys, what is this? Well, I got log base 5 of 4x minus 7 equals log base 5 of x plus 5. So I look at that. Ultimately, I need the inside of the log, right, to be the same. Because let's say if it was log base 5 of 20 equals log base 5 of 20, that would be equivalent, right? So honestly, all I care about is I want to know what x value will make the two insides equivalent. Ultimately, that's what I'm checking for. So I'm going to solve for x. Do some quick math here. So I get 3x equals 5 plus 7, 12. Divide by 3, and I'll get x is 4. Now, something with logarithms, you do need to check for extraneous solutions, okay? Stuff happens. You do need to plug into a log because problems with logs, there is a domain issue in a logarithm. You need to have, for your x values, they need to be greater than 0. Okay? So, I can't, or inside of a log, the inside of a log, we'll just put the inside, needs to be greater than 0. Log base whatever to 0 of 0 is not a value. Your calculator will spit out a not real answer. Same thing if you get a negative. So what I'm going to do is check it. I'm going to plug a 4 in here. So 4 times 4, that's 16. Minus 7, that's 9. 4 plus 5, that's 9. So I get log base 5 and 9 on both sides. We're good. So we're always going to check for an extraneous solution on each one of these problems. So now, what if I want to solve for x, but there's not logs on both sides? Well, ultimately, your steps for this problem is get the log alone. Alright, so make sure there's not anything in front of here, there's nothing added to the back half or anything like that. Then you're going to want to convert to exponential form. So just like when we got stuck in exponential form and we went to a log, we're going to go to convert exponential this way, and then we're just going to solve. So I'm going to convert here, so I got log base 5 of x equals 3. Well, log is alone, right? This information, log with inside, is alone. So now I got to convert to exponential. So the base of my log, 5, to the third power is x. So I know x is 125. plug it back in, no negatives, nothing. And if I tried on my calculator quick, I'd go log 125 divided by log 5. I get 3, which is the correct answer. Let's try another one. Well, the log is alone, right? I need to get this base out of there, so I'm going to solve here. So x to the 5th is 32. So I just convert it into exponential form. Well, I'd have to take the 5th root, right? Because that's how I can undo that 5. So 5th root of 32, that's 2. And some of you are probably saying, well, Marsh, 2 to the 5th is 32. Definitely, you could have done that one without doing the whole 5th root business that I just did. And I plug it back in. Well, that works. That is perfectly fine. Log base 2 to the 30 of 32 is in fact 5 if you plug it on your calculator. So let's try another one here. So I got, notice guys, this is inside of the log, so don't have to worry about adding that 4 over because it's inside the log, can't do it. So we're going to convert. So I got 2 to the 3rd is equal to x minus 4. Convert this or simplify that. It's an 8. Add 4. So I get 12 equals x. Check it. 12 minus 4, that's 8. No worries. It's not 0 and it's not negative. So it's definitely an okay answer. Last one of the night. Notice guys, we got a lot of extra stuff. So I gotta take care of the extras. So first I'm gonna add 3 to both sides. Get 2 log of x equals 8 divided by 2. Get rid of that 2 out there. So that's log base x equals 4. I gotta convert, right? Because I'm down to just log. But what's the base on that log? What was it if there's not a base there? Oh yeah, 10, right? Because it's a common log. So if there's no base, gotta write a little 10 there. So I get to convert. So 10 to the 4th equals x. Or, in fact, my answer would be 10,000. So my x value, 10,000. Check it. No negatives. Not 0. We're all good. Now, sometimes this will happen. You got to be careful on those checking. Notice not a single one of them happened this time. But trust me, guys, you need to be cognizant and worry about it once you get a value out of a log. Plug it back inside to make sure you actually do not get an extraneous solution. But with that, that's the end of the video. See you later, Sabers.